Okay, so hello and welcome back again to the next part of the programming bootcamp. My name is Gabor Sabo. Welcome back, Nora.
Hi.
We are we are going to, so just for those who jumped into this video, this is the series, and this is, I don't know how many, like 8th part, I think, or 9th part of the series. This is the website where you can find the rest of the series and where you can find the slides as well. So
your screen is not showing yet.
thank you. Yes, it's always a problem. I can stare at my screen and then explain.
Yeah, that's better.
All right, thank you very much. So here you have the screen, and then this is the link where you can find both the slides and the content, actually, all the videos. So I just show you that if you click on this link, if you get to the Code Maven website, now I should put here a link. So I'm going to put here a link. I don't have the link here yet, but now I can go to the archive, and in the archive, the screen, the resolution is not that good, but you will find the Programming Bootcamp for Scientists. That's the title of that, and here now you have all the videos, one after the other, and in case you would like to see each one with how long they are. And I'm going to add all the rest, and I guess on the front page you'll have the link to this as well. And the slides are here if you click on this link, and then you can get into the slides, and this is the main page of the slides. And we left the previous video at almost at the end of the numbers chapter, when we talked about the exercises, and we're going to talk about the solutions now. But I wonder if you have any questions, anything regarding to the exercises, regarding anything so far in the course.
Yeah, actually, I was doing some of the exercises, actually all of the exercises that were at the end of this chapter. And I had one question. So when I finish writing my script in the text editor and save it as a .py file, and then continue on trying to open that with a double click from the file explorer, it runs the program essentially well in a separate window. But when I get to the end of the program, this was actually the number guessing game, so it requires some answers. And when I get to the end of the program, the last print command, I suppose it comes out, but the window closes so quickly that it cannot be read at all. So I was wondering if there is a solution for that.
Right. So first of all, I think I started it at the beginning somewhere in the video, in the course. I mentioned this, not this. I mentioned part something related to this, but I didn't really show you how it's done because I didn't know how to do this. So in Windows, you can associate a file extension to some action, to some program. So you can associate the .py extension, for example, to Notepad++. So when you double click on a file which has a .py extension, Notepad++ will run and open this file as an editor. On your computer, .py is associated with Python itself. So when you double click, then it runs immediately. And maybe that's a better solution, but then you encounter exactly this problem that the program runs, and when it's done, Windows will automatically close the window that was open for running, and you don't see the final result of it. So first of all, let me switch to the file explorer that you're using, and let's see how this happens. First of all, the association. So, by the way, forget about this green thingy here. It's just one application that puts these green signs on each file. So I can right-click on the file and then say properties. So first of all, I could say open with, and then I say run this with something, or I don't know. Because so if right now I double-click on this, sorry, I single-clicked. If I double-click, it says it doesn't know how to open it. because the .py is not associated with anything. And I can now here, I can select something, find an application and associate it, and tell Windows to open this specific file with that application, whether that would be Python or an editor, doesn't matter. But that's, I think that's just for that current double click. If I go and right click on the file and I go to the properties, then I can have, there is this entry of opens with, and this is unknown application. That's why it doesn't know what to open with. So I can change this, more or less the same window that we saw earlier, that it offers me to select one of the applications. So here I can find all kind of things that I have, and I have no idea now how to find Python, but in order, so I could open, look for another app on this PC. I'm not sure, how do I, python.exe. I need to search for it, so I don't know. Anyway, that's how you associate. So you find a exe file, which I don't know how it's going to find it for me. I don't know if this is here or it's still searching. Anyway, and then you click on the OK, and then you have the association. So, okay, so that's how you set the association or change it. So what can you do to stop Windows to closing that window? I think basically nothing, not with Windows. The only thing that you can do, and now I won't be able to show it because the association doesn't work for me, but the only thing that you could do is if you edit the file, and it's per file, then you will have to do it per each file. And then here, when the program ends, let's say even at the after the main or whatever, you put in input and done. Press any key to, I don't know, close, whatever message you say. And then when the program runs, and then the last thing it does is arrives to this input statement that asks the user for some input. And actually it's not any key, it should be here enter, because only if you press enter, only then it will continue. Okay, so it's just like, it is basically as if we were asking for some input from the user, and then when the user types whatever, doesn't matter, when the user presses the enter, then this continues. Normally, you would assign it to some variable, like we do it here, lines 2 and 3. But in this case, we don't really care actually about the input. We only wanted Python to stop running until we press the enter. So that's sort of a workaround, I would call, not really a solution, because now if someone runs the program on the command line, they also get this extra input thing, and it's unclear why do you have it. Once we go over how to create a GUI application, then this whole thing will make much more sense, because then you will have a GUI with buttons and menu items and whatnot. So you probably have you will have a close menu item or button, and the rest will just work. Okay.
Yeah. Okay, that makes sense.
Okay, so I don't think that you can tell Windows now it's red. You see, because I changed the file. Okay, so whatever. Yeah, and I might come back to and actually check how to associate, or do the association later on, and I'll actually present this in the next video. I don't want to spend the time now with looking for how I actually do this, how to find the Python on my computer. So did you do the exercises? Right. Yeah. Okay. So let's just go over them. If you have any questions specifically for with the exercises, then.
No, they were kind of like, obviously the second one, you were asking the question, how could we make sure that the 3 fruits are different? Mm-hmm. I couldn't manage to do that. I had a couple of ideas, but we don't. I mean, we haven't covered how to loop yet in this course, so I didn't know. But I suppose we'll talk about that later.
Okay. Yeah. Sure. So in some of the exercises, I do ask things that you haven't learned yet. Partially so people can search if they want, because that's actually so. Some people, when they see my course, some people who actually have a lot of experience already and see my course, and they say, "Okay, Gabor, you're explaining too much. You should tell the students, okay, just give them directions and let them search because in the internet, because in the end or at the end you will have. I mean, I can give you so much and that much and not more, and you will always encounter all kind of new things that you'll have to find what is the syntax of something and how to do something. So that's a skill that all of us who write program need to have, because no matter how long you program or how much experience you get, you'll always have it's just going to grow, so we will have just more questions. Okay, so there is the number guessing game. That's the first level was we used the random run range to generate a random integer between 1 and 21, and because of how ranges work in Python, this means that it's either 1 or 2 or up till 20, so it's 21 not included. And so I called it a hidden number because that's the computer thinks and it doesn't tell us. Now in my actual solution, I actually print it out, so the programmer can actually see it as and see that when I type in that right number, it actually finds it. So it's obviously in the real game I wouldn't have this line, but without this, I won't really know if the program behaves correctly or not. So I ask the user now to guess. This is the user input. That's just a variable name, doesn't matter. I print it out again to make it easier to see what's going on. And I convert it into integer because you remember this is a string, even if the user types in the number 3. And at this point, this will blow up. So it will raise an exception if the user typed in something else, not an integer. And then I check if the guess is the hidden number. If it is, then, well, it's a hit, good. And then otherwise, I check if it's less than the hidden number and give the appropriate message. And if even that's not true, then I give the last possibility. So the guess is too high. So the order of these two conversions doesn't matter in the end. At least not now. So whatever you picked, it's good. Okay. So that was that and the fruit salad was right. I'm not sure how did you do. So probably did you use did you use a sample? No. No.
No. I just used a random choice.
So like random three times.
With three different variables, yeah.
Yeah. Okay.
And then printed those out.
Exactly. So maybe I should have that solution as well. So I'll add that later to the sides, so people can see that this is usually how people solve. But if you read about the random module, then you will see that there is the random sample, which gives you, if I remember correctly, that actually gives through 3 different values. So, and then you can actually probably even tell sample. So let's try to find it. Python random, and then
yeah, I did search for that
sample. Yeah.
code.
Right. So this is you give it what it say, the population, and then the K is how many you would like to have, and it gives you whatever. So you read it, okay? I don't want to read it, okay? But that's the point and that's partially, I think, was the point of this exercise, of the extra part, that you can search for it, and for some of these relatively basic requirements, you will have a built-in function, okay? And I'm saying relatively basic because it's all totally depends on your case. For some people, this is an absolutely complex thing. For other people, this is just basic things. And then other people in other areas have different, what it means complex for them and what means basic, okay? So, but I really recommend to search all the time for answers. And so I remember when I was teaching my son Python, and he came with all kinds of solutions. And actually this happens all the time in courses as well. Just in courses, I don't have that much time to do this because so many people are there. So people come and give some solution and show a solution, and the solution for some problem, maybe 15 lines or 20 lines. And then I can show in many cases, how can you write the same thing with a built-in function or a function there, and it's going to be shorter. And actually that's a very good way, I think, of learning, that you do something, you solve a problem, and then you show it to someone who has a more experience, or even to your peer who might solve the same problem in a different way. And then you get feedback for your solution, and you might get ideas how to improve your solution. And that's, I think, way better than just hearing the best solution, whatever, because you already thought about it, you already understand the problem, and now you see, okay, that's a better solution in some way. Maybe it's a built-in function, so I don't have to write so much code. And actually, so that's another thing that's like in the world, many people think, many measurements go, how many lines of code you wrote. And they're they say, oh, this person can write 100 lines of code a day, and the other person is even better, can write 1,000. But at the end, each line of code is a liability. It just plays for more bugs. If we could solve a problem with less code, that would be better. So even though productivity is sort of measured by many people, how many lines of code you have, but in fact, we would like to have less lines of code. So if you can write the same thing with less lines of code, but still readable and understandable, that's usually better because you have less places to make bugs, to create errors. And by the way, the word bug, so especially when I tell it to biologists, they're like, okay, what bug, what is, why are you talking about bugs? So the story is that in the original, one of these huge computers that were like room-sized computers, there were actually bug in the electric wire, and that caused the problem. And that's why, that's the story at least. That's why an error or problem is called a bug in a program. Okay, so yeah.
That's just a fun fact.
Yeah, but it's yeah. So anyway, so this is a random sample, and then it will give you just a random sample. Okay, that I think there are 3 different values. Okay, so next chapter we are talking about comparison and Boolean values, and I just updated it because I wasn't really satisfied with the order of things, and I hope that it's now better. So first of all, if statement, we get back for a second to the if statement. We can write a conditional statement like this. So we say if, and then we compare 2 values, whether x equals to 2, and if it's true, then we do something. Otherwise, we do something else. And the else part is, we know that it's optional. You don't have to write it. And one thing that I would like to point out is the colon here, because I mean, you probably already remember it, but this is something that I notice many people miss a lot of times. So both the colon and the indentation and so on, these are important things. And yeah, okay, so here I can compare, and in this case it was 2, and then I compared it to 3, and in that case, of course, it wasn't equal to 3, so printed the other part. That's so far is okay. But here we are comparing with equal, equal. And we already saw this, but let me just give you a page for it. So these are all the conversion operators. So we have the equal, equal, and the not equal. So this says equal, this says not equal, and then less than, and all of the others. And you can compare numbers with this. But you can actually compare also strings with this. So in the first example, we have 2 numbers, and we compare them. And then in the second, and this is x is less than y. That's why, because, well, 2 is less than 3. And then maybe I should show you an example. Okay, and we'll see another example. And here we have 2 strings. So it's snake and steak. I don't know, I couldn't come up with better words. And then I check if x is less than y, and says, yeah, x is less than y. So how do we compare 2 strings? What is less and what is more? It's based on, it's like the alphabet, it's like an ABC. So it's like an alphabetical order, more or less. So not exactly, because it's related to how the ASCII table is ordered, and how in the end Unicode table is ordered. So I meant the ASCII table is basically is a table of all the Latin letters and lowercase letters, uppercase letters, the digits, and a few of these characters that you usually use, like exclamation mark and so. So when we compare 2 strings, what happens is that we compare the first 2 characters based on their location in this table. And I put here a link now that leads to the Wikipedia page. There is this, somewhere here there is this, the list of characters. So you can see that this is the character, and then this is the decimal value of that character. So here you can see that the capital A is 65 and the capital B is 66. So A is less than B. But you can also see that the lowercase letters are all higher up. So the capital B is less than the lowercase a. So this is not exactly ABC or alphabetical order, but it's ASCII-betical, or actually it's based on the Unicode. If I'm not mistaken, it's based on the Unicode table, which is just much bigger. So actually, let me try to show something here. We get into Python, and then I say 2 less than 3, and it gives me true, because 2 is less than 3. So what if I put the string 2? Okay, yeah, and 2 is less than 11. That's still true, right? Good. So what happens if I ask if the string 2 is less than the string 3? So it's still true, right? Because in the table, the 2 digit was in front of the 3 digits. So what happens if I ask the same if 2 is less than 11, the 2 strings? It's gonna be false. Because the conversion goes that the first character 2 compared with the first character 1 here. And 1 is before 2. So that's that can be tricky if you forget that you didn't convert the 2 strings to numbers and then compare them, and then the conversion is not what you expected because it's comparing the strings based on that. Right. The big no-no though is comparing a number with a string. So if I scroll down, so you see what you will receive if you compare a number with a string. Actually, let's see the example. So here I have a number and a number. I compare. Okay. let's show it here, and then I go back to the slide. So what happens if I compare the string 2 with the digit 3? I get this exception. It says type error, less than in this case, because that was the operator, not supported between instances of string and int. So it more or less explains why that you can't compare a string with an integer, and that's clear. The problem was that in Python 2, it worked. And it compared, I think it actually compared the letter S with the letter I, because that's the name of the type, which is totally like, I have no idea how this happened. but that's now in Python 3 that was solved, because it's much better to get an error, say, okay, you can't do this, than to get some really strange result of, okay, this is less than the other, just because their names of their types is some way. Anyway, the example that I actually have here is something which is also interesting, or showing this, but in slightly different way. So first of all, this line. What is this? Do you recognize this?
This should be a ternary operator.
Right, so this is the ternary operator. We say that this expression has the value yes if x is greater than y, otherwise it has the value no. And now we can assign this expression to a variable. So the variable will receive either yes or no. And actually in both Python 2 and Python 3, this will be yes. And here I have two strings, and now in this example, I didn't even use the variable anymore. I only use it in the first one, so it's gonna be clear that this is separated to a print, nothing to do with the print. And here again, it says no because of what I showed you also, that 1 is less than 3 in ASCII. And then in these two cases, so in Python 2, we would get yes and no here. In Python 3, we get the exception. And that's, in my point of view, that's the correct thing to do. Okay? So,
one quick question. What happens if you compare floats to integers? Those are two different types as well, but they're both numbers.
Right, so let's try it. 2 is less than 2.0, for example. False. Equal. It's true, okay? So I think Python will automatically convert the integer to float and then compare the two.
Right, okay.
So, but actually so I didn't know it. I'm really not sure exactly what these things work, but I check it. And that's the part of the interactive shell. That's the value that you can quite easily check things. Okay, so we have this if statement, and in if statement we had a condition, but we can combine conditions together and have a more complex if statement. So in this case, I have a variable called age and also a variable called name. And in the first exception, I check if the age is greater than 0 and at the same time less than or equal to 18. So whatever, it doesn't really matter. I just try to make up some comparison, and then you do something here, and otherwise you do something else. You don't even have otherwise the else part. The point is that we have these three operators: the and, the or, and the not. The three words that you can use to combine conditionals into a bigger condition. And now I have to again mention that in other programming languages, instead of the word and, they usually use two ampersand signs. So like this. This is in other languages. And instead of or, they write the pipes twice. The character above the backslash. No, sorry. No, you see, of the backslash, right? Just next to the enter. So that's the pipeline. And instead of not, they usually use the exclamation mark. In many other languages, so just in case you are wondering, in Python, these operators, the operators are the words and, or, and not. Partially because Python tries to be more similar to English than these signs. Okay, so you just have to get used to them. And then here in this example, I have an or, so either this is true or this is true. So it doesn't matter which one is true, we'll get this. And then I can also use the not here, and it says, this must be true and this must be false, because this must be true, okay? And I could have used exclamation mark here and without the not here. That would be the same and probably would be clearer in this case. I just wanted to have some example with not, okay? In more complex example cases, you will feel when you need to use which one. Okay, so this is just an extra slide to show you that again these three operators and how you can use them. Not really that exciting anymore. That I have the first one. What is interesting or is what we call the Boolean truth tables. So these operators are either called Boolean operators or logical operators. I think both words are used for them. And so these are the truth tables. So if you have something and something else, then both of them can be either true or false. So you have actually 4 possibilities, and here are the results. So the result of and will be only true if both are true, which is logical, and that's why they're called logical operators, right? And with or, it's going to be false only if both are false. And not is just swapping between them. Okay, so if it was true, then it's going to be false, and false, it's going to be true. Okay, so we also mentioned that in Python, there are these 2 Boolean values, true and false. Other languages, okay, I think I have it in the command. Other languages, so some languages have these special signs for trueness and false. Other languages usually use 0 to represent false and 1 to represent true, or some languages is the opposite. So it's just a mess. So it's better to have the words, the actual objects. So what can we do with these true and false things? So first of all, we could just assign the true to a variable and the false to the variable, and then we can ask the user, actually if x, okay? And now I'm not asking if x is less than 3, I am asking if x actually has true in it. Okay, so that could be useful. Also the same with y, and I'm just showing that in the first case it will say x is true, and the second case say y is false, because that's what I gave them. Okay, but later on but I mean this is not, it doesn't look useful. So later on I'll show you a couple of use cases for this. Okay. What's interesting is that besides the one that we did here, that we assigned actual true to x or false to x or y in this case, if we do the comparison, whatever comparison we do, that comparison expression actually returns the true or the false. So in this case, I just printed them out. So it says it's false, this is true, whatever. Okay. If we compare none to none, that's true. But if we compare none to false, it's false, because these are 2 different things. So remember, false means false and none means I have no idea. Slightly different, or very much different, depending on your point of view. So you can print out the result of a comparison, but you can also take the result of the comparison and assign it to a variable. So what happens here, this strange expression here, strange looking expression, is that first Python compares x to 2. This will result either in true or false, and then this value, the true or the false, will be assigned to the variable v. And then we can either print it or we can use it in the if statement as we did earlier. Okay. And so two use cases. One of them is what we call a flag. So sometimes it's an input from a user. You only care whether that input is there or not. So for example, you write a program and you would like it to be more verbose. Okay, that's one of the thing that you would like the program to print out more stuff as it is working. Or sometimes people add these print statements to their program for debugging. So you can run it without the debug printouts or with them. And normally you would run without them, but then the input is only whether you would like this or not. So it's only true or false. So there is, you use a variable, and that variable contains either true or false, not a number or string. Here, for example, what we have is we ask the user for some input, and then we check if the input is correct, is what we expect. And then we set this, what we call a flag, it's like the general term for it, to true. So in this case, the flag starts out with false, and then we ask the user something, and if the user typed in the correct answer, then we set the flag to true. And sometimes this goes, and we haven't learned loops yet, so sometimes this goes in a loop, and then you ask the user several times, and they want to see if you get the right answer. Or you might go over a file looking for something, and so at the beginning you say, okay, you have a flag found, we set to false because you haven't found it yet, and as you go through the file, when you find it, you will change the flag to be true. And then when you are done, then you can look at that flag. Maybe you need several flags. Maybe you have you are looking for several things that and you would turn them on as you find them. So that's one of the uses of a variable that contains either true or false. A special case of this is what we call a toggle. It's like a button that you can click and it's on, and then you click again and it's off now. It's some places the light works there, some places even the elevator works this way. So in this case, what we have is we have a variable that we put false in it. You can see I printed out, it says false. And then I say not that variable, and it will convert to the other one. And now it's true. And if I say not again, it will convert back to false, because not will just convert the false to true and the true to false. So this is how you can toggle with something. And then maybe you'll have some input, and based on this input you do this or whatever. Okay, but this is like a special case of some flag that you can switch back and forth. There is something called the short circuit. So if you have a Boolean expression like this, something or something else, okay, or and, doesn't matter, both and or does this short circuit. What Python does is it doesn't check all the conditions, all the parts. What Python does, it says, okay, let's check the first one. Now, if the first one is true, then it doesn't matter what is in an OR case, then it doesn't matter what the second is, because the whole expression is going to be true. Because we know that true or false is also true, and true or true is also true. So the second part doesn't matter. And for an optimization, basically all the programming languages say that, okay, if in an OR statement, the first expression was true, then we don't check the second one, which is a nice optimization. We don't want to waste time doing something that doesn't affect in the end the outcome, right? And it happens with AND as well. So if the first expression is false in an AND statement, then it's no point to check the other one, right? Because the other one doesn't have any impact. Except in this case, when the example doesn't work, so actually in Python, it's not that easy to create a bad example for this, but which is nice. But so just think about it that this sort of works. So in this case, the check salary function not only compares the salary to some number, but also changes the salary. So now if the check money is true, then this is not going to be checked, which also means that the salary is not going to be increased. And this is what we call a side effect, which is a problematic side effect of the comparison. Okay? And most likely you wanted the salary to be increased every time you get to this condition. But because it was in the second part of the OR statement, this can happen. So the right answer here is just don't do two things inside a comparison. Okay? And in other languages, it's much easier. Languages that have the plus operator that Python doesn't have, it's much easier to fall in this mistake. Python, because of this, it's a bit harder in Python. But in any case, the way to solve this, so if you really have these two functions, then the way to solve this is to first do the calculations. Then you know that they are both executed, and then compare just the results. And then you know that this is going to be executed, and so the salary is going to be increased. Okay, that's sort of the solution in such cases. But in general, this script, this function is whatever. It's a red flag or whatever. It's a bad thing. Usually the recommendation that every function should do only one thing. So maybe this one increments, the other one compares. It's not easy to do this, okay? So it's especially when you start programming, you just want it to work and you don't care so much about being nice or whatever. But with the time, you can do that. You can improve with this. Okay, so there is a couple more things in these Boolean things. One of them is that instead of checking if X, so when I ask if X, it doesn't check if it's the word true, if it's it also can check any other value as if it behaves as true. Okay, so if I have 23 in this X variable and I ask if X, Python will say yes. So it is true. It counts as a true statement, true value. Okay, and if I ask and basically this, given that x is a number, this is the same as comparing it to 0 or not being 0. And if I ask if y is now 0 and I ask this, then it will say that it's false because 0 counts as false. In general, Python say that anything that's sort of empty, it counts as false. So none, okay, that like we don't know what it is, that counts as false. If I ask, it's not equals to the false value, but if I ask if something, then it will say no. 0, the empty string, false, that's what we already know. And then these we haven't learned yet, but this is the empty list, the empty dictionary, an empty tuple, all kind of other things can be empty, and they all are false. And if they have some content in, then they're gonna be true. Last slide. Okay. So I encountered this incorrect use of condition in many cases, especially beginner start to write, because you talk, when you speak in English, you say, I want to do something if the status code is equal to 401 or 302. That's how we speak, right? So someone would just type in if status code equals to 401 or 302. But what this actually does, it checks whether the status code is 401 or whether the number 302 is true. So this, it doesn't compare this to the status code. Okay, so what you probably wanted here is this. If this variable, I can't even say it anymore, is 401, or it's 300, or this one equals to 302. And an alternative way that we haven't learned yet is using the status code in, and then you give it a list of possible values. Okay, that's we'll learn later on, but I just wanted to point this out because I see this kind of mistake quite often. Any questions remaining with this Boolean things or?
No, this is actually one thing actually. So when you said that we write if X and then nothing else, then the program looks at it if X is true, right? Yeah. And then we put the number in it. Is that going to be true only because it's a number and not empty? Or could you write anything in it other than false? Like if it's some statement in a string, then could that make it false at some point?
Right. So if we put a string in it, an empty string, that would count as false. Right. If you put a string with some content, anything, even if we have a string that has a 0 in it.
Right.
Okay, because now it's a string. It's not the number 0. It's the string that has a 0 in it. Right. And that is actually true. That is so, counts as true.
And could you write like in a string false, but because it's a string, that would be true again, right?
Sorry.
So if you write like X equals in a string, like you write false in there.
Oh, the word false.
The word false, yes.
Yeah. Oh, right.
Then it would be true, right?
Yes.
Okay. Okay.
So if X, then print okay, and then it says okay.
Right.
Yeah. This is maybe you need to be a Perl programmer, not a Python programmer, because the Perl programmers do this.
Right. Okay.
Okay.
No, it was just a bit confusing, but yeah. Okay.
Yes, it is. It is confusing because some people like to play on this, and that's like the whatever.
Okay.
Right. So the word false is actually true, and yeah, it's confusing, and actually it's also a thing because some people sort of don't get at first that this false and the word true are as they are without quotes. So they are not a string; they are a name in Python, just like print is a name. Okay, so it's a function.
What would be the type of true and false in Python?
It's a bool.
Okay, so Boolean.
Yeah, and also for true, it's a bool.
Right.
Okay? And on the other hand, if I type in false as a string, then it's a string. Okay, so yeah. By the way, so that's one more thing that this is actually how you learn programming. You have come up with all kinds of these questions and then to try it, and that's how you learn. And then the other thing is that you take the exercises that I have and then you try to extend them, come up with all kinds of other ideas of what can we do with this, and come up with your own ideas of whatever you'd like and try to implement them. And maybe at first it's going to be too difficult because you haven't learned all kinds of things yet, but then you'll go and learn them because you want to do this. So that's especially if you pick up something more interesting than my exercises, then it's going to be easier. Okay, so the exercises is write a script that asks the user and receives two numbers and compare them, tell me which one is bigger. And the other one is other exercises do the same with strings. Okay, but right, I haven't showed it yet, I think, but let me just quickly show it now, because here I have this thing that so the simple one is just to write a program and tell me which string is ahead of the other, less than the other one. But then we use the comparison operator. But you can also use the len function on strings. So we can say len ABC. Maybe I showed it. Yeah, I think I showed the len. So it gives me the how many characters are in there. And so you can write here two scripts, one of them comparing the two strings as ASCII, and the other one comparing them their lengths. And then you can combine the two scripts and write a one that asks the user for a string, then asks the users for another string, then shows this sort of menu, so prints out all this, and waits till the user picks either number 1 or number 2. And then based on that, I mean, enter, says enter 1 and then enter. And then based on that, does the conversion either as based on ASCII or based on lengths. So that's going to be a little bit more complex, but that's more interesting, hopefully. Okay, so these are the exercises. Now we go to for a break of the video. You can do the exercises unless you still have a question that I need to answer before you get.
No, I think all good.
Okay, so thank you very much again for this watching this, and please do the exercises, and then we come back to the next video checking the exercises, checking the solutions, and going on with the next chapter.